What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. So in this video we are going to look at part 3 of our Pandas tutorial series in Python. So as you guys know, this is forming part of a tutorial series called Data Science / Analysis with Pandas. Okay, now if you guys have been following along with this tutorial, what you'd know is that in the previous video, right, we got introduced to a kind of a value, I would say, and that value was called NaN. Okay, so as you see here, I ran the previous script and we had NaN. Now, in this video, we are just going to observe a few more. We're going to start the video off by talking more about this. Now, you see guys, NaN is basically, as I mentioned in the previous video, it's used to denote a null value, okay? It's used to denote null or missing values. So missing values, right? That's what NaN is used for. You will frequently encounter NaNs, null values, when you are working with data science or data analysis, especially if your data sets are, big. Now, let's kickstart this video off with just experimenting with a few more methods that I'd like to introduce you to. So we will use the same cell from the previous video, so nothing to recode. We can just get straight into coding. Now, you see, Pandas has this method that is called, so let me just type this here, pd.isNull. So as you can already, guess that pd.isNull is a way for us to check if the value in a certain row or column contains a null value. So this method is going to return a boolean kind of series or data frame depending on what you use this method on. So let me give you a small demonstration. So we do pd.isNull and you'll pass the object that you'd like to proceed to check inside the parenthesis. So pd.isNull obj. Just to give you a refresher, obj is containing that kind of tweaked, indices. So basically we had a dictionary and then we had defined some explicit indices here, and then we overrode the indices in the dictionary with that of the array. So that's fine. Now this is what we obtain from the raw form or the default form of that series. Now isNull is going to basically do a boolean check on each value to check if it's null. Okay, so NaN will be isNull will check pd.isNull. The first row is going to be checked and this will evaluate to true because there is NaN. This will evaluate to false because it's not missing, it's not null. Okay, there is a value here, so that will be false, this will be false, and this will be false. So let me run this just to show you guys, and as you can see, that's what we obtain. So nothing difficult, it just helps us to locate if there are any false values in the series or data frame object. Now there is one more that I'd like to show you. It is the opposite of isNull, pd dot not null. So that's basically the negation of isNull. So true will become false, false will become true. So basically if we negate this, we'll get false and 3 trues. So let me run this for you. So obj. So as you can see, we get 1 false and 3 trues. That's the pd.notNull. Now, you see these methods themselves, they can be called on the series object itself. So what we were doing here is we are using the notNull and isNull method from the pandas package itself. Okay, what you can do, we have a series object that is in our instance here, which is obj. So I can do obj.isNull and it's the exact same output. So as you guys will see, obj.isNull parenthesis, and here we have it. So output remains the same, guys. obj.notNull. So the only difference is from which object the method is being called. Okay, for the first one we demonstrated here, it's being called from the pandas package itself, from the code file itself. And for the second demonstration, we are calling the method is null and not null on the actual series object. So that's fine. Now, what I'd like to show you guys next is that you see, you have the ability to do, I would kind of say, very sophisticated arithmetic operations. Now, the reason why I say this is because, so I will create a new cell. So actually not. Let me just comment this out because we are working with the same series for now, right? So you see, what I'd like to basically show you guys is that now you know for a fact that, let's say we have two series, right? The first series we have is this obj, which contains that nan. So just to show you guys again, that's obj. We have that one nan in here. And let's suppose that we have a second series, and I'll just copy this code here. I'll paste that there. So it's a simple series. I don't need that. I just need these. So I will call this obj2. Let's see what obj1 and obj2 look like. So this is obj1. That's obj2. Now, you guys know there is a clear difference here, right? The thing that's missing in the first series is the label or the index, which is utah. Utah is present here, but it's not present here. So let me space these out for you so you have some idea of what you are looking at. Now, you see, that makes things more readable for us, guys. So, California, Ohio, Oregon, and Texas. There's no Utah. Utah is in the second one. Now, we are going to perform some arithmetic on these series. Now, you may ask, how can we perform arithmetic on two series that do not have matching labels? Now, this is exactly why I say that pandas series objects are really very powerful, because they will automatically align themselves to the indices that match amongst them. Okay, so that's how the computation will take place. So now that we have obj and obj2, let me show you a simple math operation. So I am going to comment these out. I don't want these objects being printed to the screen. So print obj plus obj2. Now have a look at this, guys. So this is what we have. We have two NaNs. Now you see, this is because of what we call data alignment. So let me comment this here, data alignment. This is a new topic we are introduced to in this video. If it makes sense, that is excellent. If it does not make complete sense, there's no need to stress about this, because we talk about this in much more detail at a later stage. For now, what you'll notice is that as books even show us, and what you'll find when you go through books, is that they tend to introduce all concepts to you, or as many concepts to you, in the initial stages of a certain chapter. Okay, and it is explored in detail at a later stage. So my videos on the channel will kind of feature a similar experience. So you guys should know now that data alignment is a feature that is automatically supported by series objects in Python. Okay, so you see, that's what we have there. Now, one thing I'd like to mention to you, right, is that it is very logical now to think of these automatic data alignment processes as the joins that we have. So you guys know it's like a join. If you have worked with SQL or any database, joins are basically what we obtain when we take two or more tables and we attempt to merge them when applying different criteria. Okay, so I hope that makes sense to you. Now you see, essentially what has happened here, we have attempted to merge these two series. California exists in one and it does not exist in the other. Utah exists in one and it does not exist in the other. And therefore, we have NaNs that display for California and Utah, because those are the ones that are not common across both the tables, whereas Ohio, Oregon, and Texas are common across both tables. So all we did was take their values and sum it. Okay, so I hope that makes sense to you. Now, let me show you another cool kind of feature. Now, you see, the series, right, and the index on the series, it has a built-in method, okay, and the method is called name. So let me show you. So print, let's do obj dot name, and I want you guys to just have a look at this, and let's do obj dot name. Now I want to show you guys something, right? Obj name dot name is equals to, let's do population, and let's do obj dot index dot name. Let's do state. Now, please guys, this is very important for you to pay attention to. I am commenting this out. I want you guys to first view, just as a refresher, what does obj look like? This is obj. Okay, now what we are doing with these methods, the name, so obj.name, that is being called on the object itself, on the series object itself, that table, and obj.index.name is being called on the indexer column. Now what we are doing is we are giving each of those axes, or each of those objects, which is the table itself and the indexer column, we are giving a name to those objects. Now we are giving the name of the series or the table, we're calling it population, and which basically tells us that this little table is going to display or depict population, and we are giving the indexer column the name of state. Okay, so that will help us infer now that this little series or table is showing us the population for these specific states. Now, if that made sense, that is excellent. If it did not, don't stress, because when we run this code and when you see what the series now looks like, then that will all make sense to you. So take a moment to look at this, guys. This is what we had, and this is what we have. Notice that state, a little text here which says state, appears as the header row of the indexer column, which tells us that we have the names of states here, and below the informative little description of the series itself, or the table, we have a new attribute that shows up. First only data type was showing up. Now we have a second one, which is name, and it is saying population. So that tells us now that the name of this series or this table is a table that contains the population for certain states. So I hope that makes sense to you. Okay, that is fine. Now another interesting thing that we can do, right, is, you see, you have the ability to kind of alter an index, and you guys know, right, that it is possible to actually do that. Okay, so let me give you an example. As it stands now, this is our series object. I want to change the names of the indices manually for the existing one. So let me show you how it is done. What we'll do is obj dot index, and I will have an array object, and I am required to pass a new name or new indice value for each existing one. So I have 1, 2, 3, 4. I have 4 existing indices in my indexer column, which means when I'm renaming or as a reassigning names to them, I will need to provide exactly 4. So let me show you how this is done. So let's do maybe let's just keep this simple: A, B, C, and D. Okay, or we can just keep it standardized. Let's just do Durban. So these are names of places in South Africa, in case you are wondering. Let's do Durban. Let's do Pinetown. Let's do maybe Clifton, and let's do Schlanger. Okay, so Control Enter and pay careful attention to this, guys. As you can see, the indexer column has now been assigned names that have been changed. There are new values that show within the indexer column. Now, this leads me to talk about another very interesting and important point. Please pay attention, guys. If you have observed, pay careful attention that this line of code here, index.name, despite being coded in the script, it is not showing up in the series that has its indexer column readjusted or renamed. This is because you should only change the name, provide a title to the indexer column after assigning names itself to the indexes. Okay, so I hope that makes sense. That explanation was kind of difficult to say, but I'm going through it again, right? What I'm saying is that the only time you will have the ability to change the name of the header row of the indexer column is after, okay, after assigning names to the indexer column. So if I run the script again, what you will see is that state does show up. So basically it all stems down to order. Just pay careful attention to the order of these lines of code. So that's fine. Now we are going to end the video here, guys. We have covered a good amount of, I would say, concepts pertaining to the series object in Python. In the next video, we are going to move on to the next interesting data structure, which is called a data frame. So we will have fun with this. And just as a small insider, I want you guys to think of a data frame as two dimensional array, right? Think of it logically as being a two-dimensional array. So that is fine. We are going to end the video here, guys. Thanks for watching. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.